purpose of this project is to regulate temperature water by using LPC1768 microcontroller, temperature sensor, computer interface display, heater and cooler. Also need to maintain water temperature about 55 until 80 degrees Celsius. Then all data temperature sensors that have been read by the microcontroller are gonna show on the display. For the hardware setup, connect all devices on the microcontroller. One port for computer interface. One port for sensor to read temperature. Two ports for control on-off heater and cooler. Then proceed for the software development and communication device. Use software like Kyle U Vision to control and set up a system for LPC1768 microcontroller. With that, microcontrollers can communicate with sensor temperature, heater, cooler and computer interface. For the control system, a microcontroller is going to control heater, cooler and temperature sensor devices. The function is to maintain a temperature about 55 until 80 degrees. By turn on-off the heater and cooler system to regulate water temperature. The temperature sensor, which is LM35, is used to read temperature values. Which function to decide to turn on-off the heater and cooler system to regulate water temperature. This is our flowchart. Let me demonstrate this flowchart through animation. Put the pan filled with water on the heater system. Then add a system for maintaining temperature by adding sensors and other equipment. This temperature sensor is going to collect data about water temperature. Then proceed to the next process. Which process to decide to activate the heater. If not on the heater, then proceed to shut down or system off. When on the heater, it will increase temperature. If the water is below 55 degrees, then keep the heater on to gain more temperature. After gaining a lot of temperature, the sensor is gonna measure if the temperature is more than 80 degrees or not. If the water temperature is not more than 80 degrees, the system already maintains the temperature. If it is more than 80 degrees, this will activate the cooler system to reduce and maintain temperature. If still operating, let it on and keep maintaining temperature for this system. If not, proceed to shut down or turn off the system. This is our overall setup for project temperature control, which is a heater, cooler, Arduino and sensor LM35. For Arduino and equipment setup, LM35 is used to read temperature. Left leg connects to 5V VCC. Middle leg connects port A0. Right leg LM35 connects on to the GND ground. For other equipment resistors, LED light, buzzers are set up on the breadboard. Then arrange like in this circuit diagram. Can see that one path circuit for green LED which connects on port D6. Also one path circuit for red LED and buzzer connect from port D7. Ground part connects to the GND ground port on the Arduino. This is code for Arduino. This part is gonna assign LM35, green and red LED. Then, this part functions to make LM35 read temperature. The main part of this code is the if, and, else statement. Which function to set condition. This conditions for low temperature and trigger red LED. This function is to trigger a green LED when the temperature is 55 until 80 degrees. Also this function triggers a red LED when the temperature is more than 80 degrees. Then compile and run this code. This is a data log, which will show temperature value from time to time. This is graph data, can observe the gaining and decreased data pattern value when measuring temperature.
Is our assignment by using this problem statement instruction. So the problem is I need to do a coding to this assignment. There are three types of number of water temperature that is range from 55 to 80 Celsius. So for the first part of the coding, it explains that using the GPIO 0 to off or on the heater by shift 18 time left or shift 20 time left 1 to bit 18, shift 1 to bit 20 to off the heater to start the conversion. So shift 1 to bit 24. So the result, the shift right by 4 and plus bit. So if you put 0.55 volt, it will on heater and will on GPIO2. So if you put 0.8 volt or above, it will on the cooler, so off the heater. Else for the normal temperature, it will off cooler, off heater, is returned to normal temperature. So next I will run the coding itself. So we will open the AD converter, analog to digital, and then GPIO port 0, GPIO port 1, and also the GPIO port 2. So GPIO port 2 will react as the output, so the LED itself. So you run first the coding itself. So as you can see, is the LED. So now to do the first part of the coding, we need to on it first. So by turn it on, and now from none to now, I will put the value of 0.14 and then set. Now you can see inside the address 0 itself, you can see here it's peak and peak at bit 20. I put 0.81. So now it's changed, mean that it's for the volt above. So now I put 8.81. So it's mean that it on the cooler and off the heater because it's now over hot. So next I will put the 0.6. So you can see this untick at here. So you can see here it off the cooler and off the heater.
Here I will show the result after run the coding. I will change the temperature 54 below 55 Celsius. The heater connected to GPIO pit 20 turns on when the temperature drops below 55. The heater will switch off when temperature rises back to the range of 55 to 18 Celsius. So I will change 81 over 18. The cooler connected to GPIO 0 pit 18 turns on when the temperature exceeds 18. The cooler will turn off once the temperature drops below 18. So I will change 16. And the heater GPIO 0 pit 20, the cooler GPIO 0 pit 18 is activated. For example, at a temperature of 16 Celsius, both the heater and cooler remains off. So at the GPIO 2 interrupt, the LED connected to GPIO 2 pit 0 is configured to blink, indicating that it is simultaneously checked and unchecked.